Hi guys, I'm Manoj Godabi, pursuing my BE in Sri Venkateshwara College of Engineering, Department of Computer Science and Engineering. Today I'm going to explain about an autonomous agriculture robot using IoT under the guidance of Dr. Bama, Department of CSC, SVCE Bangalore. These are the contents of my presentation. Here comes to the introduction. About 40% of world's population relies on the agriculture field. Apart from traditional farming, recent years have demanded the applications of autonomous vehicles in agriculture. The main motive for developing agriculture automation technology is decreasing the labor force. Reasons are the needed for improved food quality, robotics, and artificial intelligence achievements offer solution in precision agriculture to process related to seeding, harvesting, weed control, grow supervision, chemical application, etc. to improve the productivity and efficiency. The applications of instrumental robotics are spreading every day to cover further domains as the opportunity of replacing human operators provides effective solution with return of no investment when more conservative issues are granted by the robotics heavy chemicals or drugs despite manure or fertilizer spreaders etc. are activities more and more conserved by the development of unmanned options. All kinds of agriculture robots have been researched and developed to implement several agriculture products in many countries. This agribot can perform basically elementary function like spraying the parasites. The applications of agriculture machinery in precision agriculture has expressed an increase in harvestment and research due to the use of robotics application in machinery design and task exclusion. Precision autonomous farming is the operation guidance and control of autonomous machines to carry out the agriculture task. It motivates agriculture robotics. The goal of agriculture robotics is more than just the applications of robotics technology to agriculture. In India, approximately 60% of citizens are depending on agriculture. The annual income of citizens obtained from agriculture in today's digital world, many farmers are still using traditional methods in their field, so wild of planets is very less. Applying novel technology in the field will solve the main issues in agriculture. IoT is among the fastest growing technologies. In case of planet growth, automation is necessary to monitor several environmental conditions. The proposed system is based on monitoring and watering system for agriculture, while based on Internet of Things, which helps the farmer to apply new modern method can increases their income with less manual work. Nowadays, traditional agriculture is changing modern agriculture. Currently, many agriculture applications have existed which became a business. Improvements in agriculture contribute to national economic growth. An automatic system can apply to all kinds of agriculture field. Internet of Things is connections of physical things to operate devices which the help of electronic components. The processed system mainly works on connecting the internet to main system in the planet field. Smartphones to check the result. The internet connected to device Viva smartphone which is acts as Wi-Fi to monitor and other devices to see results. Raspberry Pi processor is the computer that can be used for all kinds of projects. It operates under the Linux operating system. Python language is used to dump in the processor. The processor operates at 3.3 volts. Memory is 1 GB RAM. Raspberry Pi processor will be applicable for objects, real-time applications, and computer applications. A server web application is developed. The application has two parts, script and programming and coding. The application shows the same result as monitored by the sensor with the help of HTTP protocol. A hypertext markup language is used to code application. The backend language is JavaScript. Result observed when login is done with IP address in the application along with the results in web application monitor also continuously displaying result until the system shut down. To monitor direct connections with the border in case of laptop, putty software has to be installed. More in the speed of internet makes result observation with a fraction of second. Code mounted for server in flash method. The main aim of this work is develop monitoring and watering system of agriculture to solve problem faced by farmers in India. Coming to proposed system. The proposed system focuses mainly on the design, development and the implementation of multi-process agriculture robot with irrigation system and real-time monitoring. The sensor probes are installed at various points to measure the parameters of interest. The data is sent to the server and stored in the internal memory. The information is visualized through its web interface and the user can take action by controlling the irrigation system through the web interface. Whole system. The robot works with the battery. The robot requires 12 volts battery to operate the system. It uses Raspberry Pi model for the function in the robot. The recover consists of 4 wheels. A leveler is made and water pump spray is used for water spraying. The entire mechanism of system is controlled by the IoT model from the Android mobile. All the components are connected to the Raspberry Pi. The coding is done in the SD card inserted in the processor. A microprocessor is connected to rover. The motors are connected to the microprocessor. We have an app in the phone for movement of rover. When we are giving instructions in the phone, these are given to the cloud. From rover, the cloud gets instructions. The protocol used here for the communication between farmer and irrigation system is MQTT, mean message telemetry transport. The measured parameters are entered from sensors to cloud from the cloud server. The app reads the parameters. The IP address is used to connect the device. SSH protocol is used. MQTT is implemented in PAHA library. These are the system requirements. The hardware requirements are Raspberry Pi or Intel Edition. The sensors used are temperature, moisture and light sensors. The actuators are relay and motor. The power supply should be 9 volts. The internet connection is required with Android mobile. And the software requirements are for addition, Linux operating system is required. The languages is used are JavaScript and Python. This software can be installed in Windows 7 and above operating system. The IoT protocols are MQTT, SSH, HTTP. This is the flowchart for the proposed system. Initially, instructions are loaded. Based on the instructions, sensor detects the readings, camera mode is on, and detected data will be sent to the cloud. Based on the data, the user interface detects the moisture, whether the moisture content is low or high. If the moisture content is low, the pump will be on or else off. Later, the parameters are balanced back to permissible levels and the sensor remeasures the parameters repeatedly. These are the advantages of proposed system. It can save water and time as you do not have to personally go to farm to do watering, and the watering system supplies the right amount for the plants as excessive watering may affect the growth of plants. Coming to the conclusion, this robot is successfully implemented and tested for water spraying. It was developed by integrating agriculture robot. Various parameters like soil condition, air covered by the robot, and weight of the material for leveling are analyzed for different motors. Advantages of these robots are mainly useful in automated weed control, usage of fertilizers based on soil condition, soil sensors for drip irrigation in rain feed areas. The proposed system is mainly used for crop establishment, plant care, and selective harvesting. In future, it can be extended by using ultrasonic sensors and camera for performing the same operations without human operator. For measuring the various parameters like soil condition, area covered by robot, and weight of the material for leveling. Thank you.